So we're going to do a little test on this one.
This is a test. This is only a test of the 3D Printing Llama Company.
And what this is going to be about is structuring your 3D prints to make them stronger. Is there a structure that you can install when you're designing a 3D print to make it stronger? Now, if you ever looked at any of my designs for mechanical parts, quite often around like my motors, I will zigzag the surface, especially around like my stepper motors. I originally started doing it because I figured it might help with cooling. Whether it does or not, it doesn't hurt anything, saves a little plastic, but it also should make it stronger. Now, in theory. Now with 3D printing, it's a little different than the rest of the world, but if you don't get what I'm saying here, you take a piece of paper and you hold it up, it's got no strength. If you look at a piece of cardboard, it's got the zigzags inside. That's what makes cardboard stiff. Same with paper. Or if you look at a semi-truck. If you look at a semi-truck, the sides of a box truck is just sheet metal. And what they do is they pleat it back and forth. For vertical access. It'll stand up and it actually has strength. Something like that. Okay. So what I'm thinking is you can do the same thing with your 3D prints, but I don't know if it actually physically works with 3D printing. And I'm assuming, depending on how you build the layers, it can change whether it helps, hurts, helps more, helps less. So what I'm thinking I'm going to do is make a stick, have one flat, have one pleated, do them in different relationships so the layer structure is different, and see if adding the pleating strengthens it, weakens it, has no effect. Now, this won't be really scientific because I don't have like high-end, pressure testing tools. So anyways, we're going to try this, see if pleating or putting, pleating into your prints on certain faces, if it actually makes it stronger than just a flat face. And let me show you exactly what I mean.
Failures later.
So I'm going for round 3 here. Round 3. Alright, what I'm doing is, get this out of the way, here's my rig, kind of changed a little. I have the structural piece I'm trying to break, I have the scale, and then I have a squeeze clamp. Pretty simple. Now I also have this camera I'm going to put on it so it does a really accurate reading, because this is doing 120 frames per second. So it can get a really good reading on my boards. And what I do is just swing it out in front of it. I get it, I can see it on my little iPad there, so I know it's reading properly. Hopefully this all works after the 3rd time here. The first 2 times I had errors. One of them, the battery was going bad on the fish scale. And that's all it is, the fish scale. The second time was just errors on my own. So what I'm going to do is give it a test shot. This is just a flat one, it's a test one. I'm going to turn it on. This is broken free. So I'm going to zero it out. Then I'm going to bring it up. And I'm going to start recording. Now I was just going to have some pressure on it, but as it goes down, ooh, that was quick. And of course the low battery light came on again. Yeah, gotta be kidding me. Alright, well, fail number 3. Let's get some new batteries in there and try it again.
Attempt number 4.
Let's bring it over here a little better. How I'm mounting these is I just have a board with a screw. These little tabs are just a straight bar basically. Some of them are ribbed, and that's our testing. Some of them are ribbed. Some of them are just flat. They have a single hole. The screw goes in through the hole, traps it down, holds it. This little lip here, this little lip right here holds the strap. Everything's kosher. I'm just having fun breaking stuff. Spin it down, let it dangle. So the pressure weight is zeroed for this. Zero it out. Make sure it's reading. It is reading. Let's put some pressure on it. Let's start recording. And it's taking pressure now. Let's slide it right out to the tab. Oh, that was quick. Now that one was with the lines, the layers going across. That was awful quick, even for that. So here it is. That was the 4 standing, so when it was printed standing up. So the layer lines are going across, so it broke right on the layer line, quite obviously. So let's try the flat. Now this one was printed flat, so layer lines are going this way. So it should have a little more structure. Zeroed. Am I getting a reading if I pull on it? Yes. So let's start pulling. Let's record. And let's start pulling. And it's climbing, and it's climbing. And we're at 5 pounds, 6 pounds, 7 pounds, 8 pounds. Now this is pounds, because that's what this scale does. 11, pushing 12, 13, 14. Well, it's flexing, but it's not breaking. It's pretty cool. It's pretty strong. There it goes. Hopefully this high-speed camera caught that. So that was the 4 flat, non-ribbed. Zero out to scale, so it's just the weight. Again, I'm measuring it with the weight on there, so they're all even. Let's start recording. We're up to 2, 4, 6, 7, pushing 8. Now again, this is with the, ooh, I hear it cracking it around 8.5, 9. This is ribbed, but we're breaking right across the layer line, and there it goes. So right around 8.5, 9. This is actually sort of working. Now, of course, this is going to take longer because this one here, as you can see, I should probably show you. This one has ribs, where these don't. And the point is will these ribs make this stronger? And I did one flat each. These were printed flat. And these two were printed standing up. So obviously they broke right across the layer lines rather easily. But I still think the ribs held up longer than the flat. Go straight. And I know this isn't exactly scientific, but it's fun breaking stuff. Alright, and here's the last one. It's actually already zeroed out. Make sure it's actually working. Yep. It's taking weight, so let's put some weight on it. Oh, let's start recording. And this one is the ribbed printed flat. Restart it because I reset something. Alright, is it at 0 and is it taking weight? Yep. So let's try that again. Alright, we're at 3, 5, 6, 7, 10. We're well past what the standing up layer, where it was breaking across the layer, or with the layer. Now we're trying to break it across the layer. We're at what, 16, 15, 16, 17, 18, 19. Ooh, I hear it cracking. 19, We're over 20 and it's flexing, but it hasn't actually broken. I did hear a couple of layer cracks. And it's just gonna let me keep going. It's just bending at this point. Which I think the other one did too. Oh, look at that, huh? So we're close to, keeps relieving itself, but we're in the upper 20s. Mid to upper 20s, mid 20s. And then the Velcro broke before it did. But it never actually broke. But then neither did the other one that was flat across the layer lines. Well, it broke more. So, come to a conclusion with my semi non-scientific setup. And you can look, these were both planted flat. This one has ribs and this one does not. That the ribbing actually helped structurally. I mean, sure, I guess. I mean, this is actually still pretty hard. It's stretching. These were all with eSun's PLA Plus. There it goes. So there you have it. There's the breaking. Here, let me show you. Of the little sticks with ribs. It's far from perfectly scientific, but I think we can come to a conclusion that it does help. I mean, even in the where the layers were going across, here, it still held up much longer and much better than it did when it was just a flat piece. So, who knows? I'd like to see a more scientific approach. If somebody has the equipment to actually do it, maybe we can con Stefan over at CNC Kitchen to do it. You there, Stefan? Probably doesn't watch my little itty bitty YouTube channel, but you never know. Anyway, have fun. If you think about it, if you're designing parts and you need them to be structural, adding grooves, lips, zigzags, whatever you want to call them, adding structure to your faces can definitely make the print stronger. Have a good one.